Have you ever been working in your Revit electrical project and you insert light fixtures that are hosted and they look great on a flat level ceiling, a recessed fixture, a surface fixture, but then you put them on a slope ceiling, they look great here, but when you look at plan view, you get this weird skewed kind of fixture look to it and there's no symbol, it doesn't show up properly. Well, in this lesson, I'm going to show you how to create a custom family that comes in with the symbol properly, but you can slope it how you want to match your ceiling. So we were going to get deep in the weeds on a step-by-step video on how to create a family that slopes. So let's get right into it. So I'm in Revit 2023 and we're in this residential project that I did a full series on earlier. But we're back to this project to take a look at one issue, and that is sloped ceilings with light fixtures surface mounted to the ceiling. Now, if you haven't seen that project series, I'd recommend you go back and take a look. I walk you all the way from A through Z on how to get this thing designed out, both lighting and power. But let's take a look at this. This second story of this building has severely sloped vaulted ceilings. And if we cut a section through it, you'll really see what I mean. So what I've done is I've linked this architectural model into my electrical template, and this is a section through the building. There's the first floor, has a nice flat ceiling, flat and level, and you've got some fixtures hanging down from it. Second story is a different story. It is slanted ceilings. I'm using my custom light fixtures that I use in projects. Let's say on the first floor, if I bring in a surface circular light like this, I'm going to drag it in, and then it wants to place on a face on a ceiling. This is a hosted light fixture. Then I bring it in and it looks like it can go on any of these flat level ceilings, as you can see here. Now, for the symbol of this fixture, I'm just using the extrusion. It's just a circular fixture. I'm using the extrusion outline, and then in the middle I have a symbol in there that allows me over here to turn on emergency mode. Now, if this is an emergency light fixture like in a commercial building that either has a battery backup in it or it may be connected to an inverter or to a generator, so it's being used for emergency reasons as well, I can turn that symbol on and off. Now, that's a symbol. Symbols only show up if the family is placed on a surface parallel to the sheet. So flat ceiling works fine. If I go to the second floor, and this is where I have sloped ceilings, if I try to place the same light fixture, and I have place on face, you will see that I'm getting an obscure slanted look to this symbol. And it doesn't even place well. It doesn't follow the cursor. So let me place this right there. Let's take a look in sections, see what we have. It actually mounts to the slant, which seems great. However, symbol-wise, it's not. It looks kind of funny. And I can't get to the emergency symbology, an annotative symbol that's built within it, because it's not parallel to this floor. So how do we solve that? Well, what we need to do is create another custom light fixture that remains parallel to the floor for its symbol, but has an angle parameter in it to let me move the geometry or extrusion to fit the ceiling for those 3D views if I want things to look somewhat realistic. I'm not going for full rendering here like an architect might, but I would kind of like this to look proper in my sections or in my 3D views. Another example is bring in a recessed downlight. Up here, light, recessed downlight. It comes in and it is pure symbol. There's no extrusion at all showing in this. I want this all symbol. It's a box around a circle. Again, I have my emergency graphics that I can turn on and off. If I bring that into the second floor, we get the same kind of mess. And that is, we see the geometry of this kind of a cone, recessed, a true recessed downlight. And let's look at the section. There he is. It is recessed into the ceiling and it's diagonal, but I get no symbology below it. Symbols are gone. It's just a mess of an extrusion. So let's see how we can start from scratch and create a light fixture that has an adjustable angle to make this symbol look right and the extrusion look right. Now this will be a more advanced family editor lesson. So you want to make sure you have some of the basics on how to create extrusions and reference planes, things like that. This is going to be a little more advanced and it gets a little tricky. So hang on for this adventure. Let's get into the family editor. So I'm going to File, New, Family. Now we have all these templates that pop up. We want to go to English Imperial here in the US. I personally don't do lighting calcs in Revit because it's more of an area zonal cavity method. I like a point-by-point method, so I use a third party. However, if you do want to use the area lighting calculation in Revit, then you want to start with a lighting fixture. It will have a light source built into it. So we'll start with that. Now, there's a lighting fixture ceiling based. We do not want that ever. We never have ceilings in our linked models. We only have surfaces or work planes, not true ceilings. And then there's a wall-based. We don't want that. So we want just pure lighting fixture. So let's just open that. Now we are in our family editor. And again, I'm assuming you've been in here before. This is an advanced course. So we have reference planes that establish the center and insertion point. This guy right here is the actual light source. If you look at it in 3D, and I like to rename this to 3D rather than just view. And in here, pick a corner up here, and we can see that it's kind of a circular light source. First of all, for a downlight, I'm going to be creating a surface circular downlight. I like this to be, let's go over to edit the light source definition. I like this guy to be more of that kind of a distribution. So we have reference level, and let's go to the front view. Now what is built into this light fixture is a reference level, which again will be the mounting level. This will be like the ceiling surface. And they have a light source way above it. We want the light source to be down below our actual geometry of a light, which is going to hang down here below this ceiling. So let's go ahead and move this guy down here. Now, if I was going to build a regular surface light fixture, I would create some reference planes for the bottom of the fixture. And in the top view, reference level, I would create a circle, because this is a circular fixture, give it some dimensions in that. Now, what I have to be very careful, because I want this to slope, have a slant, I can't use reference planes. I cannot use a reference plane. I can't slope a reference plane. It has to be a reference line. Now, reference lines are very specific. If you really study a reference line, it's quite different than a plane. Take a look at this. It's a straight line. It provides 4 reference planes. One plane is parallel to the work plane, and that's this right. I can't move my cursor over it, but that's the one kind of the top right. It's a work plane parallel to the surface. It has a second plane. It's perpendicular to that surface. And it has 2 endpoints, which are called planes. So it's very different. But it allows us to anchor endpoints, and it allows us to apply some angular dimensions. It allows us to pick different planes to create extrusions on. So let's get into that. We're going to draw a reference line. I want the center of my fixture to be pinned to this intersection. So I'm going to just create a line. I'm not going to create a line for the full width of the fixture. I'm just going to create a line that starts in the middle, act like a hinge. So start there, and I'll go ahead and draw it at any angle, arbitrary angle right now, and any arbitrary length. What you can see is if I click this, you see the dashed lines. That is indicating that I'm looking at a plane that's actually right now parallel to my screen. And let me look at this in 3 dimensions. This kind of shows you what's going on. We have a reference plane horizontal, and then we have a vertical reference plane, this guy here, and then we have reference planes that are actually in the 3rd dimension at the points. So you can see that it's kind of an interesting, almost looks like a beam of some kind. So that's what's going on with these reference lines. But because we have that, we can make this angular. Now I want to pin this to this intersection. And the way I can do that, you can kind of see it. There's a little point right there. I can drag it there, or I can actually use it to mount it. So what I'm going to do is I'm going to align a line tool to this vertical. And I don't want to align the whole line. I want to align the point. See how that popped? You can see a little bit. You get there, the green line kind of pops. If I go to thin lines, let's see if that helps. A little bit, yeah. So you can see a little bit of a pop right there. I have to just start over again because I interrupted it with the thin lines. To there and to the point, and then lock it. So I locked the end point to that vertical. I also want to lock it to this horizontal to use it as a hinge. So, and what you're seeing now is I'm actually hovering over the reference level, not the reference plane. So I need to be careful to use the reference plane in case it ever needs to be separated from the reference level. So let's go tab to get to it. Now I'm in the reference plane. So I want to go from here to not the line, but to the endpoint. So that pinned the endpoint or locked it. Now let's apply a angular dimension. And I can get to dimensions either with annotate, or I can even go up to, even up top, I can hit the align dimension and then just simply change it to angular. So I want to angle again, not from the reference level, but from the reference plane up to here. And there's our angle. Click it anywhere. I don't want it locked because I want to make it variable. I'm going to make a parameter called angle from horizontal, just to be clear that we're talking about that. Now, the other thing is type or instance. I plan to do a video on the difference between type and instance and where you would use each. I mean, a lot of people understand what the difference is between a type and an instance, but what's a little trickier is to figure out when to use what kind. So in this case, let's say this fixture is going to be called type L1. All the L1s are going to be the same dimension, same watts, same volt. However, they may be mounted on different ceilings, different slopes. So I need the slope or angle to be an instance, if that helps. So I'll leave that as an instance. And it just happened to put the angle dimension over here. It's the same angle. So let's test this. We want to flex these things as we do them. So let's go up here, and we can do it here, or we can actually do it here. Click on it, and I can change this to 15 degrees. And you can see that this line is hinging nicely. Let's put it down to 10. Let's test it at 0. There we go. So, and I can't get to it from here. I have to go back here to get that back. But I have a nice hinged line, which is what I'm going to build my light fixture on now. I'm not going to build it on a reference plane. I'll build it on this line. So I want my fixture to hang down below. So next, I want to set up the diameter of this fixture. And I do that from my top view, which is the reference level. And I'm going to name this top view. Let's go to top view. There's that line I just put in. So let's go ahead and draw a reference circle. And again, a reference plane can only be a line. I need to create a reference line, which will be a circle. Start in the middle, this center point, and just draw it wherever I want. Now I want to make sure that this circle stays pinned to the insertion point. So we need to go to a center mark. That makes a little plus sign visible here in the middle. You can see it right there. And I'll go back to this. You can align the center point. So I align it to the vertical. And if I get close, the center mark will highlight, pin it there, or lock it. Same thing here. Align to there from this center mark and lock it. Now I can't move this without getting an error because it's constrained, which is what I want. Now let's put a dimension on this. Up to dimensions, let's go to a diameter. This time I like to use diameter instead of radius for a light fixture. Diameter, pull it anywhere. And let's change the scale so I can get some of these dimensions a little smaller. It's just a visual thing. And then I can also pull this. If I grab that grip, wrong one, grab this little grip, I can pull this out. And we're going to name this. We want to be able to get to this in our model. So let's give this a parameter of fixture diameter. And this is going to be a type. A type L1 is going to be a certain diameter. It's not an instance. Okay. Now we can actually create an extrusion. We'll fix the height of it later. So let's go ahead simply. We're just doing a simple circular extrusion for this light fixture. Extrusion. Circular. We're going to start it here and go out wherever. And then I'm going to align it to my reference circle and lock it. It made it a foot deep. All right, so we've got the extrusion. Let's take a look at the front, see what we have. All right, so it's there and it went above and we want it below. So let's just drag this down here. We'll set a height to it. So now we have an extrusion. Now let us flex it to see what happens. Go to the angle. Let's go to 15 degrees. Okay. Our line tilted, but our fixture did not. Now I did it this way on purpose to show you how particular this kind of family is. Normally we might not worry about where we're putting the extrusion or where we even put our circular dimension. But it matters in this case. By default, our circular dimension, and this is extrusion. Let me tab into the actual reference line circle. We created it on a work plane called level reference level. So it got put onto that reference level that is not tilting. We need this to be on the tilting line. So we can move it and all that. What I'd like to do is let's just start off correctly. Let's get rid of our extrusion. Let's get rid of our circle. Now we're going to create our circle on the proper work plane to begin with. Now the first thing we're going to do is set the work plane. We need to tell it where, just like in this picture, where do we want to draw this circle? So we need to select it. Well, how do we select it? It doesn't have a name. In fact, you can't name a reference line. We can't use that. We can pick a plane, or we can pick a line and use the work plane that it was sketched in. That's an interesting one. So let's pick a plane. How are we going to pick the plane? Well, there we go. There's our reference line. However, it's dashed line, which is showing the plane that is perpendicular to our screen. We need the one that's parallel with our screen. So hit tab there. So select that. Now we've selected that plane of the reference line to draw our reference circle on so that it will tilt. It's attached to that line. Circle, center, come out here. Now we can't apply a diameter. Why not? Well, if we look back here, this is our circle. It's tilted now. It's not parallel to our screen, so the dimension doesn't work. So now we have to put this tilt back down to 0 to work on it. You can see how tricky this gets. And this is probably one of the most complicated type of families you'll have to work on. Let's try that. Now we're seeing some dimensions. Let's go to dimension, diameter. Now we get it. Again, pull this guy out and hit the wrong one. Going to zoom in. There he is. Get him out of here. Now we can assign this to the label we've already created. So we want this to be the fixture diameter. There we go. Now we want to create an extrusion. Anytime you hit create, now we care, well, what are we creating it on? If you hit show, it'll show you which work plane you are currently creating on. So it's showing our work plane associated with that line. So we're good. So we can turn that show off. Now we want to create an extrusion circle like we did before, and then align it to this and lock it. And we're done aligning, so we'll go back to modify. Let's finish that. Now, we've created an extrusion, and it actually popped down. And a lot of that depends on which way this line was drawn as to which way the normal, the perpendicular vector. You get into some vector graphics here. So that works. I'm going to move this guy down a little bit. Let's see if it slants. So let's go to our controls and 15. There it is. Now we have an extrusion that slants with that line. So if you're getting something out of this video, go ahead and please hit that thumbs up, like below. And if you want to see lots more electrical only videos, go ahead and hit that subscribe button. Now back to the video. Now we want to get a height to this line. That can be another tricky part. I can't do a reference plane because a reference plane cannot tilt. I need a reference line. So if I go to just create a reference line, and let's just create a reference line here, like that. Now, is that going to slope with the other one? Let's test it. There's a lot of testing or flexing in this kind of family. Now it did not. So how are we going to tie that one into that? Do we apply the angle to it again? Well, we really want it to move everywhere. So one way to do this is a property of lines is interesting in that if we tie these together, create reference line, we get these tied together. Now they become one piece. If you tab it, you'll see that it actually highlights all of them. So it becomes a chain of lines. Remember how lines chain? Well, that means that they maintain their angular connection. So to test this, now let's go to a 10 degree. You see they both changed. Or if I do something more drastic, let's go to 45 so we can really see it. It changed. Now, the dimension changed, but it's still parallel to the first line. Well, to make it fixed, we need to add some dimensions to this. So let's go ahead and dimension normal aligned dimension from here to here. And we will call this fixture height. And that's also a type. All type L1s will be the same height. Now, let's see what happens. Let's go to 30. And there, it stayed fixed because we forced it to be fixed. Now we can align the bottom of this extrusion to that line and everything will flex properly. So let's align to there, from there, and lock it. So now we have it locked to the diameter, which is attached to the hinge, and we have the height locked. So we're getting there. Now, what about this guy, this light source? Depending on the kind of light fixture you have, you may want that light source to end up being attached to this sloping fixture. If you have some extreme angles like this, yes, the light source will behave differently in that space. If you only have a 10-15 degree slope, it won't be as apparent. So that's a judgment call on your part. In this case, I'm just going to leave this unattached and let it just be down here. Again, I don't use these in my calcs. So if you do, you may have to be a little more careful about that. So that's the basics of the geometry. Now let's get into the symbol. So top view. Now, as you can see, that's the top view of what it's going to look like if I were to use the geometry or the extrusion as a symbol also. Well, I don't want that to happen. So what I'm going to do, I'm going to leave this like this so that I can draw a separate circle for my symbol. A lot of people like their symbol to be the same size as their light. It gets a little tricky when you have a little 4-inch downlight. That can be a pretty small symbol. So again, make a call. What I'm going to do in this situation is I'm just going to let my symbol be the same diameter as the fixture. I need this symbol to always be parallel to the floor. Remember, if it's not parallel, it won't show up. So I need to create a reference line circle, but before I do, I need to set my reference plane. Remember, my work plane was on this sloping, hinging line. I don't want that for the symbol, so I have to set it to the reference level. And now it's showing that that's the plane it's using. So create, we can turn off the show. And let's go ahead and draw this reference circle. Same as I did before, and I'll just make it size that I can see for now. I want to pin this or lock it, so let's get that center mark visible, and let's do our align to the vertical and align to the horizontal. Those are locked. You get the error if I move it, which is good. It's constrained. Now, I also want this to be the same diameter as my fixture. Now this gets confusing. We have a lot of circles going on in here, so we have to keep track of what we're dealing with. Let's go up to a diameter of that circle. And we are going to call this one the same. We want it also to be the fixture diameter. It shrunk down now. It's closer to the extrusion now. By default, your symbol line, if you go to annotate and you start drawing symbolic lines, these are lines that only show up in the two-dimensional plan view, not model lines. By default, it will be a generic annotation as far as a category. Now, if you would like separate control of how thick these lines are, you want to create a separate line type in here. So I'll do that here as an example. This is a more advanced lesson, so we can do this. So let's go up to Manage, and under Object Styles, we can create a new subcategory called, let's call it E, something like E, so it stands out as it's electrical, and we'll call it Annotation. So our annotations are going to have its own category that we can thicken versus generic annotations. Let's make it 4 for now, and it can be adjustable in the actual model. So we're going to draw with that to go to Annotate, Symbolic Line, and we want to pick our new E-annotation category. And this is going to be a circular shape from the center anywhere, and then I want to align this to this new circle that I just put in and lock it. So there's my circle symbol, and it will change size. Let's flex it with the diameter, fixture diameter. Let's go to 1 foot. There it is. It shrinks down. Now the last piece of this is my little emergency on or off symbol. That's a separate symbol that's annotative that I need to bring in. So let's load that. Insert emergency symbol right there. Now I have to go find it. Emergency symbol, bring that in. As you can see, it's just a circle that I'll put right there. And it has some controls on it for emergency or not. Now, because this is nested into this family, I need to attach this emergency on or off button. I need to associate it with a parameter in this family I'm in now, the light fixture family. So I need to map it or associate it. Far right button associates it. And we need to call that emergency. Emergency. Now this is an instance parameter. Some type L1s could be hooked up to the generator and some other L1 fixtures are not. So I need this to be an instance. And let's call this graphics. So now we've mapped or associated that emergency on-off button with this family. And that reminds me, let's save this family. Let's save it as, and I like to give a custom name here. We'll call it a light, and we'll call it surface, circular, non-hosted, sloped. And this one's R23. I normally make families in like R22, but it's almost time to make an R24 template, so we're good. One backup. Now, before we're done, we have our most important piece in an electrical MEP family, and that is we need an electrical connector in here. So we can't forget the connector. Now, where are we going to place the connector? Again, when you create something, it puts it somewhere. It hosts it somewhere. Now, I'll tell you right now, without showing the example, if I host it to the slanted symbol, it's going to break. It doesn't like that. So I need to make sure that I host my electrical connector to a non-sloping work plane. So as long as I put this electrical connector onto a work plane that doesn't slope, I'm good. So I don't want to place it on a face. I want to put it on a work plane, and now I can select which work plane. Now I need to pick one that's not sloping, so I'll just pick the reference level. And there it is. So in 3D, there it is. Now, what do we do with those? If you've seen previous family videos for electrical, we need to map or associate some of these parameters into the family so we can get to them. First important part is on a load like a light or a receptacle or a motor, it needs to be balanced. Key number 1. We only want one apparent load that gets divided amongst all of the poles automatically. Now, one of the first things I want to map or associate is the voltage. And let me just put in a default right now. And a default, let's put a default of 15 just to get some defaults. Now, I want the voltage in there, so I'm going to associate the voltage. Again, I've done this in many other videos. If you want to go back and look, it's a type. Let's put this under electrical. We also want to associate the number of poles, map it to our family, poles, and we also want this under electrical, the electrical group parameter, so that it shows up all in the same place. And we want the load classification so we can make it lighting exterior, lighting interior, emergency lighting, whatever we want to call it. And this is going to be load classification. You can see it's trying to put it under all these different headings, which would be confusing. And then the apparent load is the last piece we need, and there's already one in here. So we'll map it to that. So now we have the 4 parameters that we need access to in our family. Another important piece we have to do is to tell the geometry whether to show up or not. We need to select the actual 3D geometry itself. So let's get to the extrusion. Luckily, there's only one here, and we need to tell it where to show up. So visibility graphics overrides this guy here, edit. From my other family videos, you'll see how this works, but we want it to display in 3D. And do we want it to show up in a plan or reflected ceiling plan? No, we don't want the geometry to show up. We don't want that weird skewed look. We want our symbol to be what shows up. So we turn that off there. Front and back, left, right. Yes, we want those to show up in elevations. And then we also don't want that to show up if we set something to be a coarse level of detail. We don't want the extrusion to show up. So we'll say okay. So that sets up the view parameters of that. So let's go ahead and save that. And we're going to load it into our project. Let's drag it in here. And as you can see, you can put it anywhere. It's not restricted to only where ceilings are because now it's not hosted. However, it wants to put it on the floor. So let's get it up to an elevation. Now this will be the trickiest part of a non-hosted light fixture is you have to actually tell it the elevation to put it into. So right now we're going at 8 feet. And there he is. Now, what we're seeing is the symbol that we drew, the detail line, not the extrusion. And we can turn on and off that emergency. Look at that. We can change the diameter of this fixture. It's a type parameter. So we can make it 18 inches if it's a nice big surface fixture. There we go. The emergency graphic here is always the same size because it's annotative. But there, that shows an emergency light. Let's take a look at the second floor now. Let's bring it in here. Look at that. Looks perfect. It's not a weird angular slope. It's got a symbol. We can see our emergency. And let's see what happens in our section. It's at 8 feet. Now, why is it slanted? Well, we had a 30 degree in our family we created, and we left it at 30 as a default. So what we can do is hit spacebar, and you can watch it. It's changing the slope, which way it's sloped. So in the 2 dimensions, you'll see that it's just spinning it around in this 2-dimensional direction. So we can use that to spin it the way we want. That's the slope that we want. So now we can move this around, And we want to match the slope of this ceiling. Well, I've already drawn a horizontal line and put it in an angular dimension. It shows it's about 46 degrees. So if we were to set the slope of this fixture at 46, apply it, now we match the ceiling slope. So you can just go up there and it's not attached, but it'll highlight when it's close. It'll snap to it. And now our fixture geometry matches the ceiling slope. And we can move it where we need to. In the center of let's move these out of the way, in the center of the room. And there we go. So now we have both symbols that show up properly. I can see my emergency symbol. And in a section or elevation or even a 3D view, the geometry will look right in the building. Now you can use this concept further. You can create a recessed downlight that slopes like this. Or you can have a pennant fixture that hangs vertically, but maybe the canopy up top you want to slope it to match the ceiling. So you can see the possibilities are endless once you understand how to deal with angular dimensions in the family editor. So if you like this kind of family editing, getting into the nitty-gritty of it, then take a look at this next video that I'm posting on the screen below for how to create another custom family. And until next time.